Yes, it's Salah Nasri here, and yes, I have a special announcement. The Game of Chips has just hit 5,000 orders on Amazon. Thank you to everyone who placed the order. The book was just released in December, so I'm very, very grateful and surprised to date. If you are someone who is intrigued, curious about how the semiconductor ecosystem works from beginning to where we are right now, this book was written with you in mind. So order it, read it, and it is pretty much a handbook of the whole ecosystem. In the meantime, enjoy the next episode and don't forget to hit that subscribe button. Hello and welcome back to the Semiconductor Leadership Podcast. I'm your host, Salah Nasri. And yes, this is a quick chip episode covering unique companies that are having huge impact in the semiconductor ecosystem. For some of you, maybe companies that you've never heard of. Today, we're doing a full deep dive into a company that most people have never heard of, but one that every single chip in your phone, your laptop, your car, and the AI data centers reshaping our world had to pass through before it reached you. We're talking about Teradyne, ticker symbol TER on the NASDAQ. Here's a simple way to think about Teradyne's role. Before any semiconductor leaves the factory, before it goes into an iPhone, before it powers an NVIDIA GPU, before it gets stacked into the high bandwidth memory for an AI server, it gets tested. Someone has to verify that chip actually works. That's the billions of transistors that are functioning correctly, that it meets the speed, the power, and the reliability specs the customer demands. And the machines that do that testing, those are made by Teradyne. But here's what makes this story really interesting. Teradyne isn't just a test equipment company anymore. Over the past decade, it's quietly built a second business in robotics. Collaborative robots and automotive mobile robots that are transforming factory floors around the world. It's a company straddling two of the biggest megatrends in technology to date, the AI-driven semiconductor supercycle and the automation of physical labor. So today we're covering it all. The founding story above a hot dog stand in Boston, the evolution of the automated test equipment industry, the AI testing explosion, the Magnum 7H, and the battle for HBM testing, the Universal Robots and MiR Robotics Bets, the financials, the competitive landscape, and where it's all headed. Let's get into it. The Teradyne story begins in 1960 in one of the most unlikely birthplaces for a technology company you could imagine. Rented space above Joe and Nemo's hot dog stand in downtown Boston. The founders were Alex Darbeloff and Nick DeWolf. Classmates at MIT in the late 1940s, Darbeloff was a natural business builder. He would later become the chairman of MIT's board of trustees. DeWolf was the brilliant engineer. And together they saw an opportunity that the electronics industry of 1960 desperately needed. Industrial-grade electronic test equipment that could verify whether components actually worked before they were shipped to customers. In 1961, they sold their first product, a logic-controlled go-no-go diode tester to Raytheon. It was simple, it was practical, and it solved a real problem. But the pivotal moment came in 1966 when Teradyne introduced the J259, the first computer-controlled integrated circuit tester. That product didn't just establish Teradyne as a leader, it effectively created the automotive test equipment industry itself. Think about what was happening in the 1960s. The integrated circuit was still a young invention. Jack Kilby had demonstrated the first IC at Texas Instruments in 1958. The Apollo program was driving demand for reliable electronic components, and as chips became more complex and volume scaled, manual testing became utterly impractical. You couldn't have a human with a probe checking every transistor on an IC. So you needed machines, you needed automation, and Teradyne built those machines. Over the following decades, Teradyne grew alongside the semiconductor industry. Every new generation of chips, from simple logic gates to microprocessors to memory chips to system-on-chips, required new, more sophisticated test equipment, and Teradyne kept innovating. The J750 for logic testing, the UltraFlex for advanced SoC testing, the Flex family, the Eagle series for high-volume analog testing, acquired when Teradyne bought Eagle Test Systems in 2008. The Magnum platform for memory testing, which came through the Next Test acquisition that same year. Each acquisition and product line expanded Teradyne's coverage of the semiconductor testing landscape. By the 2010s, the company itself had built its position into one of the most dominant players and two dominant players in the global ATE market, holding roughly 53% market share in what is essentially a duopoly with Japan's Advantest. So before we go further, let's make sure we understand what automated test equipment does and why it matters, because it's more nuanced and more important than it might sound at first. Every semiconductor chip goes through testing at multiple stages of its manufacturing process. Wafer sort testing happens while the chip are still on the silicon wafer before they're cut apart. Package testing happens after individual chips are packaged. And increasingly, system-level testing validates that chips work correctly within complete modules or systems. The test equipment itself is extraordinarily complex. A modern ATE system might cost anywhere from a few $100,000 to several $1 million per unit. It needs to send and receive electrical signals at speeds matching the chip's actual operating frequency, which for today's advanced processors means multi-gigahertz speeds and picosecond level timing accuracy. It needs to handle thousands of test pins simultaneously, and it needs to do all of this at volumes that support mass production, testing millions of chips per year per system. This model has attractive economics. ATE systems are capital equipment. They represent significant upfront purchases for semiconductor manufacturers and outsourced assembly and test houses known as OSATs. But the relationship doesn't end with the initial sale. Teradyne generates ongoing revenue from service contracts, software updates, calibration, and system upgrades. And because each new generation of chip technology demands new testing capabilities, customers need to regularly refresh their equipment, creating a natural replacement cycle. The market is also deeply cyclical, which is an important context. When the semiconductor industry is booming, when fabs are running at full capacity and customers need test more chips faster, ATE spending surges. Basic supply-demand economics. When the industry pulls back, ATE companies feel it acutely. So Teradyne has navigated through cycles for over 6 decades, building a resilient business that can weather the downturns and capitalize on the upswings. And the current upcycle? It's driven by artificial intelligence, of course. And it's unlike anything the ATE industry has seen before. So let's talk about what AI is doing to the semiconductor test market, because this is the story that has transformed Teradyne's trajectory. Here's the fundamental dynamic. AI chips are the most complex, highest performance semiconductors ever manufactured. And NVIDIA H100 GPU has 80 billion transistors. The newer Blackwell architecture is even more complex. These chips operate at enormous speeds, consume massive amounts of power, and must meet stringent reliability requirements because they're all going into data center infrastructure that runs 24/7. Testing these chips is correspondingly difficult and correspondingly expensive. The more complex the chip, the more test time it requires. The more test time it requires, the more ATE capacity the manufacturer needs. And the more ATE capacity they need, the more revenue flows to Teradyne. But it's not just about the compute chips. AI systems require an entire ecosystem of advanced semiconductors, networking chips, custom AI accelerators, power management ICs, and critically, high bandwidth memory. Each of these categories demands specialized testing. And as AI spending has exploded, so has the demand for test equipment. The numbers are by all means striking. In fiscal year 2025, Teradyne's total revenue reached $3.19 billion, which is up 13% year over year. But the acceleration was dramatic in the back half of the year. Q4 2025 revenue hit $1.08 billion, up 44% year over year and 41% sequentially. That kind of sequential ramp is exceptional for a capital equipment company. AI contributed to more than 60% of Teradyne's fourth quarter revenue, and management guided that AI-related revenue would rise to over 70% in Q1 2026. Think about that. In the space of just a couple of years, AI has gone from being a tailwind for Teradyne to being the dominant driver of its business. Computing revenue specifically grew 90% year over year in 2025, driven by the insatiable demand for testing advanced AI processes. For Q1 2026, Teradyne guided revenue of $1.15 to $1.25 billion, implying continued strong growth. CEO Greg Smith stated that the company expects year-over-year growth across all business segments in 2026, with compute driven by AI leading the way. So, if there's one product that crystallizes Teradyne's AI opportunity, it's the Magnum 7H. And to understand why, you need to understand what's happening, of course, with high bandwidth memory, HBM. HBM is the specialized memory technology that sits directly on top or next to the AI processors, providing the enormous memory bandwidth these chips need to process AI workloads. Without HBM, modern AI training and inference would be dramatically slower and less efficient. It's one of the critical bottlenecks in the entire AI infrastructure stack. And the market for HBM has exploded, as we've all seen it. The three key players, Samsung, SK Hynix, and Micron, the three major memory manufacturers, are all racing to ramp production of HBM3, HBM3E, and the forthcoming HBM4. The chips are extraordinarily complex, involving multiple DRAM dies stacked vertically and connected through silicon vias. Testing these stacked dies at every stage of manufacturing is essential to ensuring yield and reliability. And this is where the Magnum 7H comes in. Teradyne launched this next generation memory tester specifically to address the rigorous demands of HBM testing. The system is actually engineered for high parallelism, high speed, and high accuracy testing of HBM devices at scale. The specifications are remarkable. When you look at Magnum 7H, it supports high-speed testing up to 4.5 gigabits, which is absolutely remarkable. And that is per second, by the way, covering current HBM3 and HBM3E devices, as well as next generation HBM4 and HBM4E. It's configurable for up to 9,216 digital pins and 2,560 power pins, enabling what Teradyne calls superior touchdown efficiency at probe. Essentially, the ability to test more chips simultaneously per machine, which translates to 1.6 times increased throughput in mass production environments. It provides comprehensive test coverage from base die wafer test through memory core test and burn-in. And critically, volume shipments have already started ramping at the largest HBM manufacturers in the world. This is not a future product, by the way. It's in production now, testing the memory chips that are going into the AI servers being deployed today. The HBM testing opportunity is significant for Teradyne because it represents a meaningful expansion of its addressable market in memory test. Historically, Advantest, its key competitor, dominated memory testing with a roughly 60 to 70% market share, particularly in traditional DRAM and NAND. But HBM is a new category with different testing requirements, and Teradyne's Magnum 7H has allowed it to gain substantial ground. Reports suggest Teradyne has captured a meaningful share of the HBM test market, disrupting what was previously Advantest's stronghold. Let's zoom out and talk about the competitive dynamics in automated test equipment, because they're actually quite unusual and quite favorable for Teradyne. The ATE market is essentially a duopoly, Teradyne and Advantest based in Tokyo. Together, they control the vast majority of the market for semiconductor test equipment. Teradyne holds roughly 53% overall market share. Advantest holds most of the rest. And then there's smaller players like Cohu, who basically compete in specific niches. Cohu is of course strong in automotive and industrial test cells, but they don't challenge the two leaders in the high performance segments that drive the most revenue. Duopolies are by all means good businesses to be in. There's limited price competition. Customers, who are basically the semiconductor manufacturers and OSATs, need multiple ATE suppliers for supply chain resilience, which means both Teradyne and Advantest maintain strong positions. And the barriers to entry are enormous. Building ATE systems that can test leading-edge semiconductors requires decades of accumulated engineering expertise, deep customer relationships, massive software ecosystems, and the ability to stay on the bleeding edge of measurement science. The competitive dynamic between Teradyne and Advantest is nuanced. Teradyne has traditionally been stronger in SoC testing, the complex, logic-heavy chips used in smartphones, PCs, and networking equipment. Its UltraFlex platform is the workhorse of the industry for testing advanced processors. Advantest has been stronger in memory testing and has recently gained share in SoC testing, as well as with its V93000 platform. What's fascinating is how AI is reshuffling the competitive landscape. Teradyne's strong position in compute and networking test, the UltraFlex is the go-to platform for testing the most advanced AI processors. It gives it an outsized benefit from the AI spending wave. And the Magnum 7H's entry into HBM testing is allowing Teradyne to challenge Advantest in a segment that was previously titled heavily in Advantest's favor. Now let's talk about the part of the Teradyne story that makes it truly unique among semiconductor equipment companies: robotics. In 2015, Teradyne made a move that surprised the industry. It acquired Universal Robots, the Danish company that had pioneered the collaborative robot, or aka cobot, for $285 million. 3 years later, in 2018, it acquired Mobile Industrial Robots, known as MiR, a maker of autonomous mobile robots, or AMRs. These were bold bets on a thesis that the automation of physical labor was entering a new era, one where robots would work alongside humans, not in caged-off areas, but on the same factory floors, warehouses, and production lines. Universal Robots has been a genuine pioneer. Founded in 2005 by Espen Ostergaard, Christian Casso, and Kasper Stoy at the University of Southern Denmark, the company created the first commercially viable collaborative robot arms. Lightweight, flexible, easy to program, and safe to operate near human workers without safety cages. Their UR3, UR5, UR10, and UR20 cobots have been deployed across tens of thousands of installations worldwide, performing tasks like machine tending, palletizing, assembly, quality inspection, and welding. MiR complements Universal Robots with a different form factor. Autonomous mobile robots that navigate factory and warehouse floors independently, transporting materials and goods without the need for fixed infrastructure like conveyors or tracks. Together, they form Teradyne Robotics, a division that represents the company's bet on the convergence of AI and physical automation. And in December 2025, Teradyne announced a major expansion, a new US operations hub in Wixom, Michigan, in the heart of Metro Detroit, where it will manufacture Universal Robots cobots domestically for the first time. The facility represents a capital investment of up to $32 million and expected to create over 200 jobs, with operations starting in 2026. The strategic logic behind this move is clear. As companies reshore manufacturing to the United States, driven by tariff concerns, supply chain resilience, and government incentives, demand for automation is surging. A survey showed that 73% of North American manufacturers cite productivity improvement as their top reason for investing in automation. And 87% of companies already using cobots report double-digit productivity gains. Now, the robotics business hasn't been without challenges. Revenue has fluctuated with macroeconomic conditions. In 2025, the division went through significant restructuring, including workforce reductions, as the broader industrial automation market faced headwinds from slower EV adoption and weak manufacturing activity in Europe and China. Q4 2025 robotics revenue was $89 million. Meaningful, but still a small fraction of Teradyne's total. But here's the bull case for Teradyne Robotics. The cobot and AMR markets are still in their infancy. Global cobot market penetration, or total industrial robot installations, is still in the single digits. As AI makes robots smarter, better at perception, better at manipulation, better at navigating unstructured environments, the addressable market expands dramatically. And Teradyne, with Universal Robots' installed base, ecosystem of integrators, and brand recognition, is positioned to be a major beneficiary of that long-term growth. Reports has also suggested a significant deal with a major e-commerce customer is expected to be a substantial growth driver for the robotics division later in 2026, which could mark a real inflection point. So let's step back and look at Teradyne's financial profile holistically, because the numbers tell an interesting story about a business in transition. Full year 2025 revenue came in at $3.19 billion, up 13% from 2024. But the growth was heavily backloaded. Q4 alone represented $1.08 billion, or roughly a third of the full year, reflecting the acceleration of AI demand in the second half. The revenue mix tells you where the growth engine is. Semiconductor test was the dominant segment at $883 million in Q4, driven by compute and networking test demand. tied to AI. Product tests contributed $110 million, and robotics added $89 million. Profitability has been strong. Non-GAAP operating margins have historically been in the 25 to 30% range, and the AI-driven surge in semi-test revenue, which carries strong incremental margins, is pushing profitability higher. So Q1 2026 guidance of $1.15 to $1.25 billion in revenue, with non-GAAP EPS of $1.89 to $2.25, it suggests continued margin expansion. The stock has reflected this transformation because Teradyne's share price soared 242% in 2025. As the market re-rated the company from a cyclical test equipment manufacturer to an AI infrastructure play. Analysts entering 2026 were projecting further upside driven by expectations of sustained AI test demand and eventually robotics recovery. Teradyne's balance sheet is clean, with manageable debt and strong free cash flow generation. The company returns capital to shareholders through dividends and share repurchases while continuing to invest in R&D and strategic initiatives like the Michigan Robotics Hub. As with any investment thesis, there are meaningful risks to consider. First, cyclicality. The semiconductor equipment industry is notoriously cyclical. While the AI wave is providing extraordinary demand right now, the industry has a long history of boom and bust cycles. If AI capital spending moderates, or if hyperscalers pull back even temporarily, ATE demand could decline sharply. Teradyne stock, trading at elevated multiples, would be vulnerable to any deceleration. Second, customer concentration. A significant and growing portion of Teradyne's revenue is tied to a relatively small number of semiconductor manufacturers. Companies like Nvidia, AMD, Samsung, SK Hynix, and the major foundries. Any shift in their spending plans or testing strategies could have an outsized impact. Third, competitive risk. While the ATE duopoly has been remarkably stable, Advantest is not standing still. Advantest has been investing heavily in its own AI test capabilities and has strong relationships with many of the same customers. The competitive dynamics in HBM testing, in particular, are still evolving. Fourth, the robotics business is unproven at scale. Despite nearly a decade of ownership, Universal Robots has not yet delivered the consistent high growth trajectory that the cobot market's long-term potential would suggest. The restructuring in 2025, including the workforce reductions, raised legitimate questions about whether the robotics business can achieve the scale economics that Teradyne's thesis requires. Fifth, there's technology risk. Semiconductor testing is an area where customers are constantly pushing for new approaches. Built-in self-test capabilities on the chips themselves, AI-powered adaptive testing, digital twins for virtual test. If the industry shifts meaningfully towards approaches that require less ATE, Teradyne's core market could face structural pressure. And last but not least, macroeconomic risk. Trade tensions, tariffs, and geopolitical friction, particularly between the US and China, create uncertainty for a company that serves the global semiconductor supply chain. China has historically been a significant market for ATE, and any restrictions on technology exports by all means will affect Teradyne's addressable market. So where does Teradyne go from here? I'd argue it's by all means at one of the most exciting strategic inflection points in its 65-year history. On the semiconductor test side, the AI tailwind shows no sign of abating. The most advanced AI chips are getting more complex with every generation, more transistors, higher speeds, more sophisticated packaging techniques like chiplets and 3D stacking. Each of these trends increases the amount and complexity of testing required. The transition to advanced packaging, where multiple dies are integrated into a single package, creates entirely new testing challenges at the module and system level. Teradyne's broad portfolio across logic, memory, and system test positions it to capture value across this expanding test landscape. The HBM opportunity specifically could be a multi-year growth driver as HBM4 and HBM4E ramp into production, and as the stacking complexity increases from 8 to 12 to 16 layers of DRAM, the test requirements and the capital intensity of testing will continue to escalate. On the robotics side, the long-term thesis remains intact even if the near term has been bumpy. The demographic trends are unmistakable. Aging workforces in developed economies, rising labor costs, reshoring of manufacturing, and increasing willingness that basically is to deploy automation in small and medium-sized enterprises. Universal Robots' ease of use and low total customer of ownership make it particularly well suited for this SME market, which represents the largest untapped opportunity in industrial automation. The convergence of AI and robotics is perhaps the most exciting long-term catalyst, as large language models, computer vision, and reinforcement learning make robots more capable and more autonomous. The range of tasks that cobots and AMRs can handle expands dramatically. Teradyne's position at the intersection of AI, semiconductor infrastructure, and physical AI robotics is unique. No other company spans both worlds in quite the same way. CEO Greg Smith has articulated a vision of Teradyne as a company that enables the technology of today and automates the workflows of tomorrow. That's an ambitious framing, but it captures the dual thesis: semiconductor tests for the AI build-out, robotics for the automation build-out. So that's Teradyne, a company founded above a hot dog stand in 1960, selling its first diode tester to Raytheon that has evolved into the gatekeeper of the AI hardware boom and a pioneer in collaborative robotics. It's the kind of company that doesn't get the headlines. You'll never see a Teradyne logo on a consumer product, but every advanced semiconductor that powers the devices and infrastructure that you depend on today, from the processor in your phone to the AI accelerator training the next frontier model, passed through a Teradyne test system before it reached you. In a world that's building more chips, testing more chips, and automating more physical processes than ever before, Teradyne sits at the intersection of it all. It's the enabler's enabler, the company that makes sure the AI revolution actually works. And that's all for the quick chip episode of the Semiconductor Leadership Podcast. If you enjoyed this deep dive, make sure to subscribe, leave a comment, and share it with someone who should know about the companies behind the companies building the future. Until then, see you at the next episode.